Well, in problem number 25, we're allowed to use our calculator. So we're going to be using our calculators in just a little bit. They tell us that the function f is defined for every x is greater than 0. They tell us that f of pi equals 1. So that tells us that when x equals pi, the y value is 1. So we have an ordered pair. And it tells us that f prime is sine of 1 over x. And they tell us to use a tangent line approximation for f of 4. So to get our tangent line, we're going to have to evaluate f prime when x is equal to pi. So let's get to work. Now you got to be careful here. Some people start differentiating automatically, but they tell us that f prime is sine of 1 over x. And if we use our calculator, we'll see that the sine of 1 over pi is approximately 0.313. Now when we type into our calculator, we'll use more decimal places of accuracy than this, but we'll just write down 3 places for right now. And this is enough information to get our tangent line equation. And we can say that y minus 1, the y value, is going to be approximately equal to the slope 0.313 times the quantity x minus pi, the x value. Now, what we're supposed to do is use this tangent line to approximate the value of f of 4. So that means we're going to replace x with 4, and let's see what happens. Y minus 1 is approximately 0.313 times the quantity 4 minus pi. We just replace an x with 4, and if you get y by itself, we'll add 1 to both sides. So y is approximately 0.313 times the quantity 4 minus pi, and all of that plus 1. So let's use our calculator and find the y value. So we type this into our calculator. Oh, let's enlarge that a little bit so we can see it better. There we go, that's more like it. When we type this in our calculator, we get an exact answer and we get a decimal approximation. We can see that when x is 4, y is approximately 1.269. Oops. Y is approximately 1.269 when x equals 4. Or in other words, f of 4 is approximately 1.269. So if you look at the options, we can go with A or B, and that's it. So now we need to determine if this approximation is an underestimate or an overestimate. And to do that, we need to analyze this function a little further, and let's find out if this graph is concave up or concave down. And in order to do that, we're going to work with the second derivative. Now remember, we were given f prime. We're told that f prime of x is sine of 1 over x. And we can find the second derivative by hand, but since we have a calculator, we're going to use our calculator. So we found our second derivative. F prime prime is the opposite of cosine 1 over x. Oops. Opposite of cosine of 1 over x, all over x squared. And let's determine concavity. Let's see when f prime prime is 0 and when f prime prime is undefined. We can tell right now that f prime prime is undefined when x equals 0. It's not even in the domain of our function because this function was defined for x is greater than 0. So we thought about this, but we don't need to use that information. Now let's find when f prime prime is equal to 0. And again, the calculator would be very helpful for this since we're allowed to use it. Now remember, when you're trying to solve a trig equation, it's a good idea to solve on the graph screen. So we put the second derivative into the y equals screen, and we're setting the viewing window now. We're going to make the x min 0 and the x max 10 just for now. The y min will be negative 1 and the y max will be positive 1. Let's take a look at the graph. And it looks like we certainly do have a place where our second derivative equals 0. I'm going to pause the video, find that value, save you some time, and then we'll continue in just a moment. Okay, you can see from our graph, f prime prime is 0 approximately when x is about 0.637. So we go to set up our f prime prime sign chart to discuss concavity. Sorry, remember we're starting at 0. We've got about 0.637, and we can tell that f prime prime is positive for a little bit and then negative for the rest of the way. So when we're around f of 4, we can tell that f prime prime is negative. It's less than 0. Therefore, f is concave down. We don't know what the graph looks like, but we can tell that our graph is concave down. So let's just think in general. If you have a concave down graph, if you have a tangent line, our tangent line values are going to be above the graph. Therefore, our tangent line approximation is an overestimate. So we're looking at option B. We're saying that f of 4 is approximately 1.269, and this is an overestimate. Ooh, that was a character builder. Well, as always, thank you for watching the video.